Okay. Explore number 4, energy for life. The essential question: what is the difference between endergonic and exergonic reactions? So go ahead and write that out there. This comes from Living Earth 2.1.4. That's explore number 4. And tell me what you know. Tell me what you think. Pause the video there. Okay, well, hopefully you had a chance to write down a little bit about what you know related to this. Roman numeral 1, endergonic and exergonic reactions. We'll take a look first at the endergonic reactions. Simply, these are chemical reactions that require an input of energy from the surroundings. Um, because of that, they need energy. They are not spontaneous. Um, if you take a look here, I've got in red here a little note to you, and this is coming directly from your text here on the left. In biological systems, free energy is designated by the letter G, capital G, um, and it represents energy that can do work if temperature and pressure are held constant. Okay, the G stands for Gibbs, free energy there. So the change in free energy, what we call delta G, remember the symbol for change is that little triangle. The change in free energy of an endergonic reaction is positive, and that's because the products of the reaction contain more energy than the reactants. Okay, if we were to take a pen here, maybe just put this off to the side here, we're saying that we could go ahead and say something like this. If you have A plus B equals C, and we said that was your chemical reaction, everything on the left here we refer to as your reactants, and everything on the left is referred to as your products, which in this case is just the letter C. So in an endergonic reaction, we're seeing that the products contain more energy than the reactants. Okay. The products of the reaction contain more energy than the reactants. So this here is your products, right? They contain more energy. For them to end up with more energy than what you start, you have to input the energy. Okay. All right. Well, moving on to the second topic here, we're going to talk about exergonic reactions. And nice thing is, this is a short lecture here. Exergonic reactions, they release energy. Okay, remember endergonic, they absorb energy. That's why the products have more energy than the reactants. In this case, exergonic, they release energy. The delta G, the change in Gibbs free energy, is negative, as the products of the reaction contain less energy than the reactants. Energy is released into the surroundings. You can use that energy to do work, right? They are spontaneous, that is to say, energetically favorable, and they occur without the input of energy. So again, I think we use the example endergonic. If I'm cooking an egg, that's going to cook so long as I keep on putting energy into it, right? The example of a firework, on the other hand, if I go and light the firework, I need a catalyst here, something to kind of get things going. I don't have to keep adding energy to make my firework go. Once I've lit it, it occurs spontaneously, right? And that's what they're meaning by that. The products have more energy versus the reactants in this case have more energy than the products, and so they spontaneously are released. All right, well, that's this is actually some important information there, so I suggest you kind of sit there and kind of just think it over, chew it a little bit. And here on the left-hand side, you should also pay attention to this adenosine triphosphate molecule, ATP. Um, they're showing you how the three green circles here represent your phosphate atoms. They're all connected by chemical bonds. You can break those, releasing tremendous amounts of energy, and you can reattach them, which is an endergonic process. You have to input energy to attach phosphates together. So they kind of go and just show you that as well. All right. Okay, well, go ahead and write down your summary paragraph, and we'll talk to you soon. All right. Bye-bye.